All right, this video is meant to help you understand whether a polynomial function is even versus odd. So what does it mean when we ask you to determine if a polynomial function is even or odd? Well, let's first start talking about even functions. An even function, what that means, let's just start with a very simple even function like x squared. If you think about x squared, when we graph that parabola, we get a shape like this. And what that's saying is that if I put a 4 in for x, I'm going to end up getting a 16, right? 4 squared is going to give me 16. Even functions mean if you put the opposite number in, so 4, its opposite is negative 4, we're going to get the exact same result because think about this. Y equals, put a 4 in, square it, what do you get? 16. Now let's put negative 4 in, square it. Well, what's a negative times a negative? Makes a positive, so we also get 16. So they would match up here on their graphs. That is for every even function out there. That is what that's saying. So when we ask you to determine if something is an even function versus an odd function, even functions, their y values will match when plugging in opposites. So the rule is the opposite of x plugged in should produce the exact same thing as when you put the original x value in. So f of negative x should be exactly the same as f of x. And I'll show you how to algebraically determine if that function is odd versus even. We'll get to that in a second. But right now we're just understanding what it means, okay? So now let's talk about a problem, or excuse me, a function that would be considered odd, okay? So if I change that 2 right there to a 3, that's one of our most common or most well known by learners in Algebra 2, and that's going to give us something like this. So now what that's saying is if I put a 2 in, right, just like when we put the 4 in before, let's talk about putting 2 versus negative 2 in, what happens? So if I put a 2 and cube it, y equals 2 cubed, we're going to end up getting 2 times 2 is 4, 4 times 2 is 8, so we get positive 8. But now let's change it from positive 2 to negative 2. Remember in the even function, we got the exact same result. What happens here is we get a different result, but kind of a special one. So we're going to say negative 2 to the power of 3, negative 2 times negative 2 times negative 2. So let's just write that out the long way so you guys understand what's happening here. A negative 2 times a negative 2 times a negative 2. Well, because we have 3 of them, 2 negatives are going to make a positive. So we get positive 4 times negative 2. And a positive times a negative gives you a negative result. So if you look, we got positive 8 when we put positive 2 in. We got negative 8 when we put negative 2 in. So what ends up happening here is because we got opposite results, that would be an example of an odd function. And the rule for this is f of negative x has to be equivalent to the opposite of f of x. I'll also show you how to algebraically determine whether or not functions are odd here in just a second. So now that you know the basics of it, even functions, odd functions, or some functions are neither, right? You put a 4 in and a negative 4, you get 2 completely different results. They're not opposites of each other or the same. You would just say that's neither. It's not odd nor even. Okay, so now let's start giving you some examples. I'll show you how to algebraically determine whether they're odd or even or neither. And I have a nice little graph that I tell my students to make to keep things nice and organized. I think you'll appreciate that as well. Give me just 1 second to clean this up and we'll get started. Okay, here's our first example. What did I give you? Even, odd, or neither? Let's find out. So we've got f of x is equal to 9x squared minus 5x to the 4th power. If I want to determine if this is even or odd, I can just use these algebraic rules given to us up here. So they're saying if I put f of negative x in, so all I would have to do to change this from f of x to f of negative x is I'm just going to change all my x's to negatives. Okay, so what that would look like is 9 times negative x squared minus 5 times negative x to the 4th power. These x's were positive, well, now they're negative. Okay, so now, think back to when we talked about exponents being odd versus even. So if that's an even number like 2, negative x squared, negative x times negative x 2 times is going to end up making a positive number. So we can change this right now. After we do this part, we end up just getting 9x squared. And then the same idea goes here, because negative x to the fourth power, that's negative x times negative x times negative x and negative x. Well, we got 4 of them, so that's a pair and that's a pair, and those pairs make positives. So because of that, negative x to the fourth power is really just going to end up being x to the fourth power. Comes out as a positive result. Now, bring that negative 5 down, attach it to, and we've got our final result here. F of negative x is really just this when simplified, simplifying from here to here. And if you look, we have an exact match to our original f of x. So what this is saying is f of x is this. F of negative x, after simplified from here, turns into this, which is an exact match. So those are equal, meaning the function I gave you is even, okay? So what I'm going to tell you to do is we want to check and just make sure even, odd, or neither. So making a box over here is a great idea. I tell my students, make a box, say f of x, and just put in your result there. Then you're going to want to have a result for f of negative x equals, and then your last row needs to be f of, or sorry, not f of, my apologies there. F of negative x has to be equal to negative f of x, so we want to see a negative f of x also. So I'll show you on the next example what you do with negative f of x and how you would check that. But right now, we already found a match with f of x and f of negative x right there. And because those two matched, we're dealing with an even function. Okay, let me clean this up, give you another example, see if we can handle an odd function. All right, so now what we have is f of x equals 2x minus x to the fifth power. We just got done with an example that was an even function. And remember, the first thing we did was we just checked to see if it was even. I would always recommend checking to see if it's even first, then moving to whether or not it's odd, because you're going to need the f of negative x anyway. So f of negative x equals, let's do it the same way we did the last problem. We're going to change these x's to negatives. So we've got to be a little careful here because that needs to be a negative x, but this is where it gets a little tricky, minus x. So we want to put negative x in right there and raise that to the power of 5. Okay, 5 is an odd number, which means that when we take negative x and multiply it by itself an odd number of times, and just for the purpose of time on the video, I'm going to do 3 of them. 3 is an odd number just like 5. But what happens is a negative times a negative makes a positive, and then that positive times a negative is going to give us a negative result. So negative x to the fifth power actually turns into, it's kind of confusing here because there's a negative hidden 1 right there. We're just taking negative 1 and putting it to the fifth power. Negative 1 times negative 1 times negative 1 times negative 1. Well, 1's being multiplied all over the place, doesn't change it at all. So we get the exact same result of negative 1x to the fifth power. I actually don't need those parentheses anymore. That's the whole reason we're doing this, right? Okay, so we're trying to simplify this down. But now what you see is this negative comes down, giving us doubles. So we do need to throw those parentheses back in, but they should go outside of the 5 now. So subtracting a negative, we're going to be changing that to positive here in just a second. Okay, 2 times negative x, well, that's just going to give me negative 2x. So let's take a quick break, make sure we understand what just happened. We put negative x's in for this x and in for that x. I raised it to the fifth power, and because 5 is odd, we still end up with a negative result. Now we're going to have subtracting a negative, which makes a positive. And then negative 2x would come down here like so. So we get this function, and we're hoping it matches with that function, the original, if it's even. We want f of negative x to be the same as f of x. Here's f of x, here's f of negative x. It came out to that. Well, let's see if these are the same. 2x, negative, oh, we already know they're not the same. That's positive, that's negative, so it can't be even. But what I'm going to do is over here on my chart, this beautiful chart that keeps everything so nice and organized for you, I'm going to put what f of x was just to keep things nice and tracked. And then down here for f of negative x, I'm going to put what I got when I simplified it, negative 2x plus x to the fifth. But now the last and final step is we have to take f of negative x, this function, and we have to see if it's equivalent to opposite of f of x. So when we have a negative out here in front of the f of x, what you would do for that is this. You would say opposite of f of x. So here's what I would do. I tell my students, just write down what f of x is. Give yourself a little space in the front. So instead of writing it right here, give yourself some space and just put parentheses around all of f of x. So remember, f of x, 2x minus x to the fifth. So I'm going to say 2x minus x to the fifth. Now, when we say opposite of f of x or negative f of x, that negative goes right here and needs to distribute to all of the terms. So if I multiply a negative 1, which is just not visible, but there is a 1 right there, that negative 1 times 2x is going to make negative 2x. And that negative 1 times a negative x to the fifth is going to make a positive x to the fifth. Now I'm going to put a box around this because it's simplified, and I'm going to compare it to my other two, my original and my f of negative x. Before I do that, why don't we just put it over here in our chart so we have them all nice and neat in one spot. Negative 2x plus x to the fifth. Okay, we take a step back, we look at our chart over here, and we see, do we have any matches between the three? Well, if you're looking carefully, you notice that those match, which means they're equal. So it appears that f of negative x is equal to opposite f of x. And because those are equal to each other, they're the exact same, we are dealing with an odd function. So now you've seen an example of an even function. You've seen an example of an odd function. Remember, even, you put a 2 and a negative 2 in, you'd get the same y results at the same height. Odd functions, if you put a 2 and a negative 2 in, you're going to get opposite results. What about when it doesn't match up at all? That would be a neither example. Let me erase this and get one going for you. All right, our last example, we got f of x equals x cubed minus 3x to the fourth power minus 1, and we are trying to determine, is it even, odd, or neither? Well, if you've been watching this video, you can probably assume this one is an example that is neither. Because I've already gone through an even example, an odd example. What would we see if it was neither? Well, let's do the same thing we've been doing. Let's write f of negative x out and see if these match. So all we got to do in this case is just change that and that to negative x's. So you're going to get negative x to the third minus 3 times negative x to the fourth minus 1. Negative x to the third power, because it's a 3, you're going to end up getting a negative result. So we can just say negative x to the third. Negative x to the fourth, well, because 4 is an even number, we're going to get a positive x to the fourth there. And that is going to need to be multiplied by negative 3. And then negative 1 would just get brought down. Okay, well, can we clean this up? Yeah. So we get negative x cubed minus 3x to the fourth minus 1. Let's compare our simplified function, which is f of negative x, to our original function, f of x. X cubed, negative x cubed. Well, that right there tells us it's not even because they don't match up. So let's track these over here. X cubed minus 3x to the fourth minus 1. Negative x cubed minus 3x to the fourth minus 1. Well, I took these two equations from here and here. I'm copying them down in my chart that will help me compare all three of them. And notice the first term, they're opposites of each other. And so because those don't match up, this is not an example of an even function. But we need to see if this function here would be the same as taking that function and putting the negative distributed to all terms. So let's figure out what f of x is as an opposite. So opposite of f of x, we want to take negative and put it outside of this in parentheses. Our original function, f of x, we're going to write it down. Remember, I give myself a little bit of space right there. I'm going to say x cubed minus 3x to the 4th minus 1. Put the negative in front. We need to distribute it to all three terms. I draw rainbow lines back in early algebra days just so kids don't forget to multiply by all three. If you're doing this stuff by now, you know to do that. Negative times x cubed is negative x cubed. Negative times negative 3x to the 4th is positive 3x to the 4th. And a negative times negative 1 is going to give me a positive 1. Put a box around it, take that information, bring it over to your chart, and let's compare everything. Okay, now that I have what I have in this chart, I just got to find some matches. We've already confirmed those don't match. Does this match to the original, or does this match to f of negative x? Let's find out. Negative x cubed, negative x cubed. We might have a match. Negative 3x to the 4th, positive 3x to the 4th. None of these match up over here. They're all slightly different to some extent. So this would not be even, nor would it be odd. This is a neither function. So this is neither even or odd. Meaning if I put a 5 in to this function, I'm going to get a result. But if I put a negative 5 in, it's not going to be the exact same as my original 5. And it's also not going to be the opposite of my original 5. Hopefully this makes sense. This is not easy stuff, but you guys can do it. Study hard and good luck on your upcoming test.